Hi, and welcome to Stage 2 Chemistry. You'll be drawing on your past knowledge of chemistry and other things that you've learnt, plus you'll be starting to make some connections to everyday events as we work through the concepts related to chemistry at a Stage 2 level. There are 5 topics throughout the year, and you'll start to see some crossover as you start to get through the course because there are areas that aren't isolated in chemistry, and there are also connections to other areas of science. So if you're studying something like physics, biology, you'll start to see some connections coming in to chemistry and those other sciences. The first topic we're going to have a look at is topic 1, which is elemental and environmental chemistry. This year you'll be getting very familiar with the subject outline, and as we go through each of the topics you're going to see the subject outline shown. So you can see here this is parts from 1.1 in the subject outline, and you'll see the intended student learning outcomes. So it's really important that you are aware of all of these and that you check them off as we go through them, and that when you're looking at tests, this is what you can be tested on. So if it's not in the subject outline, you can't be tested on it. So there's a short video for you to watch that goes through the arrangement of the periodic table, and it has a look at subshell notation, which you need to be able to do for the first 38 elements. It identifies the SP, D, and F blocks in the periodic table. And you start to have a look at the metallic, non-metallic or metalloid nature of the elements. These then will connect back into oxides later, so metal oxides and non-metal oxides. And we will start to talk about regions of high, low and intermediate electronegativity.
In your previous learning of chemistry, you'll have seen the periodic table. You'll need this for everything you do. It's an important thing to refer back to, and it will be your best friend. You'll see that this periodic table is colour-coded. You'll find this very helpful when you start talking about electron configuration. Things that you may have heard of before, but may have forgotten, are the reasons that we have the rows and the columns. So they're more commonly called the groups and the periods. Each of these, as you may remember, are organised in a way that help us to understand how many electrons we're working with in the outer shell, and also how many shells we're working with. Helium is in an interesting location. Here on the periodic table, helium is over with our noble gases. Now the reason for that is that helium has a full outer shell, but it's a little bit confusing with it being yellow. It really belongs over here when we're talking about electron configuration. One of the key things to remember is the groups. So this blue group here is our S group. This pink group in the middle is our D group. The yellow group over here, with the exception of helium, is our P group, and down the bottom in green is our F group. For the purpose of your study, you don't need to worry about the F group, you just need to know where to locate it. Our S group is a common group that we'll be using a lot. When we talk about our D group, it can be a little bit misleading because it looks like we should start at 4D. Really, we start at 3D. So that's something really important to remember. And our P group over here is as it looks. By purely looking at the periodic table, we can get a lot of information. If we take group 1, which is hydrogen and helium, we know that they're both in the S shell. And we can see all the way down the periodic table, the S shell only consists of 2 electrons. So if we look at that, hydrogen is in the first S shell. We call that 1s. Helium is also in the first S shell. Lithium is in the second S shell with beryllium. We call that 2s. So you can see moving down the groups, we move down a level. So we have 1s, 2s, 3s, 4s, and 5s. These are the only ones that you need to worry about this year. and you only need to know up to element 38. Let's have a look over at the P shell. The P shell, we can see, has 1, 2, 3, 4, 5, 6. So P can fit 6 in it. Now, because we start at row 2 for the P shell, the first P we have is 2P. Let's have a look at what this means for writing some configurations. In the past, you will have learnt about electron shells. You may have even learnt the formula 2n squared, where n is the number of shells. This gives us an idea of how many electrons can fit in each shell. So you may remember that the first shell fits 2, the second shell 8, the third shell 18. We're going to look at this in a bit more detail and talk about things called subshells. So if we have a look at the periodic table, you can see that we have 2 in the first row. That's consistent with what we've known as being 2 in the first shell. That one stays the same. If we have a look at the second row, there's 8 elements. So that means, yes, we do have 8 electrons, but you can see that 2 are in the blue colour and 6 are in the yellow colour. So we have 2 plus 6. This means that we have an S shell and a P shell here. So if we were to look at an element like neon, let's have a look at how we might write that out using this information. So for neon, we have a look. Hydrogen. Now remember we said that was the 1s shell. We can remember that because it's in the first row and it's the S because that's the blue colour. Now hydrogen is 1s1 because there's 1 electron there. But helium is actually the second one. So we're going to say that there are 2 electrons full in that first shell. We now go down to the next row and we see lithium and beryllium. We're getting across to neon, so they're both full. So that's the 2s row. Because we're getting up to neon, both lithium and beryllium are full, so that shell is also full. So where does that take us? We go all the way across, and we're now starting to talk about a different block. We're talking about the P block. At the end of that row where neon is, we have 6 in the P. Now it's the second row, so it's 2P, and there are 6 in it. So that's how we'd go about writing something like neon. Let's have a go at another one. Let's have a go at one that's not in the middle. So something like aluminium. So the start is going to be very similar to neon. So we have 1s2, 2s2, and then we have 2p6 like we did before. We're now down to the third row. So 3s2, and then aluminium is in the P, so it's 3p1. Let's move along to something a little bit trickier. Our transition metals are the ones in this block here. Now, you may remember I wrote 3D there. That's to help us remember that this actually starts at 3 and not 4 like we would think it would. So remember we had S, P, D and F blocks. If we were to look at something like titanium, let's have a go at writing the electron configuration for that. Now you can see that titanium is element number 22. So we need to have 22 electrons worth in our configuration. And we'll do a check on that this time. So we can see row 1 is full. So we have 1s2, 2 electrons in row 1, done. Our 2s shell is also full, so 2s2. Our p shell, our 2p shell is also full, so 2p6. Row 3, our 3s shell is full, so 3s2. So is our 3p shell. If we come down now, 4s shell, that's full. And titanium is the second one in our D row, so that makes it 3d2. We can check that our answer's right by adding the numbers up. So 2, 2, 6, 10, 12, 18, 22. So we have 22 there, which means we are correct. Some key points to look at with the notation. You can see for each of the shell numbers, I have a big letter out the front. For each of the shell letters, I have a little letter, and the electrons are in a superscript up the top. This is going to be a really important thing to remember when you're practicing these, because that's how they'll be assessed in the exam. Like with any good system, there's always an exception to the rule. The exceptions we need to worry about are chromium and copper. And the exception comes in the 4s shell. Where you would think that this would be full, it's actually not. So you would go about writing it, but you would only have 4s1. Everything else remains the same except this. So let's have a look at what that might look like. So let's remind ourselves 4s1 is what we're going to end up with there. So 1s is full, 2s is full, 2p is full, 3s is full, 3p is full. Now remember it was 4s1. So let's put that at the end to remind ourselves. Then we need to have a look at the 3D shell. So where we should normally have 4 for chromium in the 3D shell, we actually need to have 5 because there's 1 missing in the 4s shell. So it should be 3d5. And remember, you can do a check by adding up all of the numbers along the top. Similarly, copper has the same rule.
Okay, so you've just seen how the electron configuration works. Here's a summarised version of it in this table, and you'll be able to refer back to those notes. Just be aware that when you write in test or exams, instead of writing HE, you'll actually need to write the electron configuration. So this is a shorthand way of writing it. You'll see it around. You need to write it in the full version. So for the case of lithium, HE you can see is 1s2. So you would write 1s2, 2s1. And we'll go down and we'll do something similar for neon. So we can see here sodium starts with neon. And neon is helium, so we go back 1s2, 2s2, 2p6, 3s1. And you would need to write it in that full form. And you've also seen this in the video that you've just watched. So you'll see here that we've got the S block, the P block, the D block, and the F block you would see down here. And like was mentioned, it is not important for you to memorise, for example, this layout. What I would be doing is making sure I'm aware of where all of the blocks are and how to use the periodic table to your advantage. You'll have enough to memorise without needing to use it on things that you can easily work out. And this is another way that you can use this diagram if you like to help you remember the structure of the periodic table. One of the recommendations is that when you go into a test or exam, the first thing you do is rip off your periodic table and write the blocks in there so that it makes it really easy when you come back to writing answers to questions. You don't need to think about that.